Alright, this is the seventh and thankfully final video of this section. We're going to look at solving equations that have multiple logarithms in them. These are going to work just like the ones we did before, but with one extra step on the beginning. First thing we have to do is use the log rules to consolidate all the logarithms into a single log. Or we might want to do that individually on each side of the equation. And after we do that, we'll proceed as before. All right, so this first one, we've got log x plus log x minus 21 equals 2. So we'll put those together to get log of x times x minus 21 equals 2. So now we will do 10, this is a base 10 log, so 10 to each side. So that gives me x times x minus 21 equals 100. Now I'm going to distribute the x across, get x squared minus 21x minus 100 equals 0. All right, can I factor that? Yeah, it looks like 25 and 4 will work. Let's see, if we make the 25 negative and the 4 positive there, then we get a sum of negative 21 and a product of negative 100. So this gives me x equals 25 and x equals 4 as possible answers. Now we need to go back and see if that makes any of the logarithms 0. If I plug the 4 in, that's going to cause some trouble here. So plugging the 4 in, that gives me log of negative something. So I can toss that. The 25, if I plug that in here, it gives me log of 25 and then log of 4. So 25 is the single solution to this problem. And we could plug this into the calculator to check, but we can really just plug it back in and check it. 25, if we look at this log of 25 plus, this is log of 25 minus 21, so that's log of 4. Using the log rules, we can put that together. This is log of 100. And so this gives us 2, which is what we expected. All right, let's do another one. First thing we'll do here is put these logs together. This is going to be log base 5 of 3x plus 2 plus, or not plus, times x minus 1 equals 1. All right, so I'll do 5 to this side equals 5 to that side. And so over here I've got 3x plus 2 times x minus 1 equals 5. All right, if I distribute this out, let's see, 3x squared minus 3x plus 2x minus 2 equals 5. And so that's 3x squared minus x. And then I'll take 5 off of both sides, get minus 7 equals 0. And now this won't factor. So I've got to use the quadratic formula on it. All right, so x is going to be negative b plus or minus the square root of b squared minus 4 times a times c. So we get this, all that over 2a. All right, so that's 1 plus or minus, let's see, if you multiply this out, you get 12 times 7, which is 84. And it's positive, so you get 85 under the radical. And then 6 on the bottom. And we can't simplify the square root of 85 because it's 5 times 17, so you can't pull any perfect squares out of it. So our two answers then are going to be x is 1 plus root 85 over 6, and x is 1 minus root 85 over 6. Let's work up a decimal approximation for both of those. All right, let's see, 1 plus root 85 over 6. This top one is 1.703. And I'm going to make that a squiggly equal instead of putting dot 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 on the end. That's approximately 1.703. And this one is approximately negative 1.370. All right, so we need to check both of these to see if they work in the original problem. And again, all we really need to do is make sure that when we plug them in, we don't get a negative or a 0 inside of either of these logs. Now, the negative number we can throw out immediately, because when we plug that into here, we'll get negative 1.3 minus 1. So this is going to be negative. So we can toss this one. The 1.703 should be fine. I say that because if you plug it into here, it's bigger than 1, so this is going to be positive, and this is 3 times a positive number plus 2. So this one's good. So that is our only solution. I'm going to circle this whole box here because that's the exact value and a decimal approximation. All right, let's see. I think this is our last example. Log of x plus 6 minus log of x plus 2 equals log x. All right, on this one, I'm going to combine all the logs on this side into one. And I could pull this log over to the other side and combine it as well, but I don't need to. Since I've just got one log on this side, what I can do is 10 to this side equals 10 to that side. And so now I've got x plus 6 over x plus 2 equals x. All right, so to solve this, first notice negative 2 can't be a solution because negative 2 would make the denominator 0. So let's keep that in mind and let's solve this. I'm going to multiply both sides by the denominator. So I get x plus 6 equals x times x plus 2. So that gives me x plus 6 equals x squared plus 2x. And if I move everything to one side, I get x squared plus x minus 6 equals 0. And that'll factor into something with 3 and 2. We'll put a plus here and a minus there, so we get positive 3x. Positive x and negative 6. So this gives me two solutions. X equals negative 3 and x equals positive 2. Okay, now we got to go back up here and see what's going to happen. If we plug in the negative 3, that's going to be a problem for this log because it's going to make it negative. It's also a problem for this log, but as long as it messes one up, that's once we find one that it gives us a negative or 0 inside, we don't have to check anymore. All right, now let's check the 2. 2 is going to, if we put it in here, we get 8, and if we put it in there, we get 4. So this one's fine. Now, it can happen that all of your solutions wind up not working. That didn't happen on any of these problems, but it's certainly possible. So you might go through here, solve this, and having to throw away all the solutions. So it's possible to get no solution as your answer to one of these. All right, that does it for this section.